Today is a big block day, but not just any ordinary big block. How about 632 inches making 1100 horsepower, naturally aspirated? Oh, and for the street. This is another giveaway project between our friends at Prestige Motorsports in Concord, North Carolina and Holley. It's a big block Chevy, and considering how well it turned out, I expect Prestige will be building this package again many times over in the future. It's just a big old naturally aspirated hog with a ton of power. The idea was to build their answer to Chevrolet's popular ZZ632 crate engine that boasts 1,000 horsepower. Now that engine is definitely cool, but it does have some drawbacks. Namely, you can't get one. People are on a waiting list for them to become available. And second, the ECU that the engine comes with is locked down. You can't even tune it without having to break in, and that, of course, voids the warranty. Holley and Prestige's answer is to come up with their own version of the 632 with off-the-shelf parts which anybody can buy and an easily tunable Holley Terminator X ECU, and Prestige Motorsports offers a 3-year warranty on this bad boy too. And let's not forget, it makes another 100 horsepower over the Chevrolet crate engine. So let's get going on this build so we can see exactly how this beast is put together. To make 632 cubic inches, you need to have some big pistons and swing them through a pretty long stroke. So our combo is 4 3/4 inches of stroke along with 4 inches 600,000 cylinder bores. In order to handle that, Prestige went with a World Products Merlin 4 cast iron block. As you can see, they already have the Ford Stroker crankshaft from Scat already installed when we arrived, but that's okay. Anyhow, the Merlin blocks come from the factory with machine bores that allow them to handle as much as 4 inches 750,000ths of an inch of stroke right out of the box. So if you're going to build a street machine that can shrug off quadruple digit horsepower numbers for thousands of miles, you've absolutely got to use top shelf components. And that's what we're starting with here. Those big slugs are 4-inch 600,000ths diameter forgings from Race Tech pistons. With a long stroke like we've already established, you need to pack in as much connecting rod as you possibly can. So the pistons have been designed with a really tight compression distance, which is the distance from the center of the pin bore to the top of the piston. In turn, that makes room for the H-beam connecting rods from Scat to be a full 6 inches 700,000ths long. Now that improved rod stroke ratio helps reduce the chance of scuffing a piston on the cylinder wall. And finally, those are coated rod bearings from King you see fitted in place on the 2-inch 200,000ths rod journals. One of the goals of this build was to maximize power through compression ratio, thanks to custom flat top pistons that are just 5,000ths of an inch in the hole at TDC and a relatively compact, at least for a big block, 90cc combustion chamber in the AFR cylinder heads. The compression ratio will be a healthy 13.2 to 1. Now that would make it a detonating time bomb in most street applications. But we'll be depending on high-octane E85 fuel and a Holley Terminator X ECU to help handle the timing and fuel maps to keep the engine safe on the street and at the track where it can really shine. The camshaft is a solid roller from Comp Cams. It's a 4/7 firing order swap, and the duration is 280 degrees for the intakes and 298 for the exhaust at 50 thousandths of an inch of tappet lift. It has 112 degrees of lobe separation, and with the 1.7-to-1 ratio rocker arms, gross valve lift will be 797 thousandths of an inch for the intake valves and 787 thousandths for the exhaust. And here's a look at the business end of the cylinder heads from AFR. And they are no joke. These are AFR's 18-degree Magnum heads. They are fully CNC cut and designed specifically for big inch, high performance big blocks. But unlike the heads on Chevrolet 632, they are a shelf stock casting and easily available from Prestige, Summit Racing, or really any other place. As I already mentioned, the combustion chambers are sized at 90 cc's each. And while the valve diameters are 2 inches 400 thousandths for the intakes and 1 inch 800 thousandths for the exhaust. The intake ports are raised a ½ inch, and when sized at big old 457 cc's as these are, can flow as much as 498 CFM at 1 inch of valve lift. To improve airflow, the valve angle on the AFR heads is rolled to 18 degrees. Now T&D has a set of aluminum shaft mount rockers adapted to fit these heads perfectly. They are lashed to 8 thousandths cold, which should get us close to the hot lash target of 14 thousandths for the intakes and 16 for the exhausts. Now, let's back up in time a little bit for this shot. Notice how these high-flowing AFR cylinder heads actually extend past the deck surface and over the China rail. This creates a big gap that cannot be covered by the intake. And just globbing a bunch of silicone in there certainly isn't a good idea. So, Larry Broker will make an adapter. He starts by making a paper pattern and then tracing it out on some aluminum plate. I think it was a 1/4 inch thick or so. Anyhow, Larry keeps the plate around for uses like this, and you can see he's already cut on it before. But after cutting out the triangles to fill the gaps between the bottom of the cylinder heads and the top of the China rail, he's ready to fit them up. There's not a lot of pressure on this area, so really the intake manifold, once it's bolted down, will provide the pressure necessary to hold everything in place. So all that's needed is a thin bead of silicone to kind of stick those aluminum triangles in place, but also provide an airtight seal. And then they were given a few hours to dry thoroughly. Oh, 1 second and we'll get right back to it. Just wanted to let you know we have our Horsepower Monster shirts in gray now. They look fantastic. Another color for you up on the store. So if your boyfriend or girlfriend or husband or wife says he wants to go out in someplace nice to eat and don't wear your usual black shirts, bam, dress grays, baby. Meanwhile, the intake manifold Prestige plans to use is one of AFR's Magnum 18-degree single plane castings. Now we'll get into more details on that in just a minute, but during pre-fit, Larry noticed that the Holley throttle body didn't perfectly match up with the throat of the tall intake. It's not a lot, but you can see the problem right here. You'll get that sometimes when mixing and matching components from different manufacturers. But instead of just saying, oh well, he actually pulled everything back apart to do a little grinding on the AFR casting until everything matched perfectly. So once that was done, we were ready for the install. You can see those little aluminum triangles Larry previously made are still in place, and he lays down a fresh bead of silicone to seal the bottom of the intake to the China rail. You can see that's a nice open path to move plenty of air through the intake and all the way to the combustion chambers as efficiently as possible. The AFR Magnum intake is cast with a Dominator-sized carburetor flange, but you already know we're running a throttle body and not a carb, Dominator-sized or otherwise. And you can see that the fabricators at Prestige Motorsports have already made a few changes of their own, welding in fuel injector bungs to turn this regular intake into a port fuel injected manifold. And dang, I've got nothing to say other than those AFR fabricated aluminum valve covers are just dead sexy. But before we continue on with the top end, I've got to take a moment to share with you what's going on with the oiling system. I walked into Prestige Motorsports shops one morning during the build to find Larry with the Moroso billet oil pump chucked up in a Bridgeport mill whittling on it. It turns out there wasn't quite enough clearance between the pickup on the oil pump and the bottom of the segmented oil pan from steps. On the billet Moroso pump, the pickup is built into the billet body. So Larry tore it apart and cut a few thousandths off of it on the Bridgeport mill. Then he cleaned it up and put it all back together. These billet pumps are a bit pricey compared to old school cast pumps, but they are super efficient for a wet sup oil pump and provide lots of flow while also eliminating cavitation in the upper RPM ranges, so it all ensures consistent oil flow throughout the engine. Of course, that wasn't the only modification Larry had to make as far as the oiling system went. Gasket manufacturers don't really do oil pan gaskets for stroker applications. So we did have some spots where the rod bolts wanted to clip the oil pan gasket as the crank swung them by. You can try to cut these with a razor blade, but the inner layer on these one-piece gaskets is often steel. So Larry just marked the offending areas and ground the clearance that he needed. And then he got it all put together while I had my back turned. I don't remember if I had gone to lunch or was working on something else, but you can't sleep on Larry because he's always working. Anyhow, here you can see the high volume fabricated Steph's oil pan all bolted up and ready to rock. Since we won't be using a carburetor, Prestige has spec'd in one of Holley's Dominator flanged 4-barrel throttle bodies, which you saw earlier. We're going to have to move a lot of air to make 1100 horsepower, so this throttle body is rated for 2000 CFM. Now, this billet aluminum body is designed with everything needed to hook up and operate well with most engine management systems and works extremely well when it comes to maximizing both power and drivability. To get that much air flowing through the throttle body, big 2¼ inch throttle bores with precise machining is required. And to prevent hang-ups, the throttle shafts are offset so that the engine vacuum will actually assist in closing the throttle plates. Here you can see the rest of the fuel delivery setup. Holley fuel rails feed a set of fuel injector clinic injectors sized at 1200 cc's each. That's awfully big, but you need a lot of fuel when you're planning to burn enough E85 to produce well over 1000 horsepower. To maximize ignition control and spark all 8 cylinders, Prestige chose to go with Holley's innovative big wire coil near plug kit instead of a conventional distributor and ignition setup with a single coil feeding power to all 8 plugs. This is a shelf stock dual sync distributor which is used to track the position of both the crankshaft and the cam for the ECU. But since we won't need plug wires, the distributor cap has been swapped out for one of Holley's billet blank distributor caps to clean up the look. For dyno testing, Prestige just hooked up the 8 Holley smart coils to a bracket that's fabricated and mounted in a convenient spot on the dyno to keep the coils away from harm. Once the engine is in the car, the smart coils can be mounted on the firewall or practically wherever the owner wants. We mentioned earlier that this engine has a really high 13.2 to 1 compression ratio, which means no matter what fuel you're burning, you're going to need very precise engine controls to keep from getting into detonation when the engine's under load. Interestingly, everything was handled through an off-the-shelf Holley Terminator X ECU, which I've already mentioned. Prestige Motorsports is one of the few engine builders, not in the NASCAR Cup Series or other professional racing level, that's invested in the capability to monitor individual O2 levels in all 8 cylinders in real time. Here, they're making individual cylinder timing adjustments through the Terminator X and included software. Now, this obviously isn't something that most engine builders or car owners are going to get into, but it's impressive that advanced capability is built right into every ECU like this. So let's get on with it and make some real pulls. On the dyno, we ran the big 632 both on race gas and E85. Now you'll notice that we did add an alternator here, which was just to provide a bit more juice to power the 8 O2 sensors and a 1-inch spacer underneath the throttle body. With race gas, we saw a little over 1,000 horsepower, but things got really fun when we switched over to E85. Now here's the dyno chart for that pull. Power jumped way up to 1,106 horsepower at just 6,500 RPM. And we never saw less than 780 foot-pounds of torque throughout the pull. 1,100 horsepower is going to be a beast in anybody's book. Plus, at say 1,500 RPM, it's going to be making at least 400 foot-pounds of torque still, which means leaving the church parking lot without squalling tires on a Sunday afternoon and ticking grandma off is going to be a tough task. But hey, we all like a challenge, right? Anyhow, if you've made it this far, thanks for watching. Please leave a like and a comment on what vehicle you think this engine would be perfect in. And we'll see you next time with another great engine build.